Hello, my name is Sebastian Chwilczyński, and I'm a machine learning engineer at deepsense.ai. And today we are going to discuss what to do when large language model is not listening to you. And we start our journey with a definition, what even prompt engineering is, because this is quite new discipline. And it is all about developing and optimizing prompts to be as efficient as possible. But you may ask a question, what does efficient mean in this context? And basically, if this is our prompt that we should develop and optimize to be efficient, then efficient means to make prompt as short as possible, because the longer the prompt, the more money we need to spend on the message to GPT or any large language model. And of course, we want to save money. And the second, we want to maximize the correctness of answers provided. So you probably know that sometimes LLM answers not the way you expect it to answer. So we want to maximize the number of times it answers correctly. And from the business perspective, these 2 points are very important, but unfortunately, they are in trade-off with one another. So with this short introduction, let me introduce you the agenda. So we will start by motivation to show you that, yeah, prompt engineering is important. Knowing that it's important, we will discuss all the tools of the prompt engineering, because you can achieve many wonderful things with it. But after it, we will discuss some problems, because it's not a silver bullet. Sometimes it just doesn't work, and it is good to know the limitations. And we will facilitate some limitations via agentic systems. Okay, so let's start with the motivation. So the biggest motivation is that sometimes the answer is just not right. So here we ask a very simple question about 2 directors, and we asked if they are of the same nationality. GPT answers no, they are not. But funny enough, right after it, we see it started explaining its decision, and it really claims that they are both American filmmakers. But since the GPT cannot trace back, it just cannot recover from this error. Okay, so we also know that LLMs have unlocked impossible use cases. So coding agents have never been better than now. But it's not only about coding. Khan Academy released their AR-powered tutor. Salesforce released Einstein GPT, which is about the customer relation management. And from completely different domain, there's a farmer chat that helps farmers harvesting in the most optimal way. But most people kind of, when you think of LLMs, think of these chat capabilities. But this is not only it. Large language model can perform excellent at rather classical approaches. As here on the slide, we have 2 classification problems. The first one is about the fake news detection, which is a very important use case. And the GPT-4, which were not trained on this particular data set, out of the box outperforms Roberta, which is a transformer classifier, and was trained on a lot of data by 4%. So we needed less effort. We just prompted GPT good enough, and it outperformed Roberta. And on the right, we have the example from sentiment analysis. It's classification again. And as you can see, ChatGPT outperforms Roberta without any additional training. And Roberta, Word2Vec, and Bow was all trained. Okay, so this brings us to different approaches for machine learning. Historically, all we had was feature engineering. We needed experts to build good representation of data that can be fit to some statistical models. Then we moved to deep learning, when we just put raw images, raw audio, raw text to some black box and expect it to train well. And now the new approach has shown prompt engineering, where we basically just create concise prompt that solves our task. And I didn't draw any arrows, because all of these approaches are still very useful. Okay, so I will be talking about prompt engineering, but generally there is another approach called fine-tuning. by which we can improve the performance of LLM to solve our task much better. But fine-tuning is all about creating additional data set that is used to train the large language model further. So we need this training phase. And with prompt engineering, the new data is not necessary and we doesn't require a training phase. Great, so we focus now on prompt engineering, but just before it, quick disclaimer. When we perform fine-tuning, we almost always need some good prompt to kind of flip the model into this fine-tuned state. Because in the data set we use for fine-tuning, very often we have some suffixes that LLM just learns to recognize and turn on this fine-tuned state. So remember about it. So knowing a little bit, we can come back and imagine what prompts possibly, of course, these are not true prompts taken from these solutions, it's very simplified, could be inside these tools. So for the coding agent, we can just ask it to think step by step, because we know that it's good to describe how the code was generated. And we want it to be formatted using Markdown. For the AI-powered tutor, we should provide it with some knowledge about solving some tasks and instruct it maybe that it shouldn't provide direct answers, but rather guide students or pupils. For the sales for product, maybe they claim that their product is grounded in the data. So in the prompt, we can really instruct model to be very grounded in data, to be careful about it. And for the farmer, we can just provide maybe some product instructions, how to use this product, and then answer all questions in Hindi. So for free, we have translations. Not only it answers about the product, but it can do it in Hindi out of the box. Okay, and with LLM, basically you can solve numerous of tasks if you can prompt good enough. And now, concrete example of prompt engineering with very simplified case. So imagine we are building some app that book vacations for people, and we have a user called Sebastian Chwilczyński, and they agreed to book some vacations. So we just need to take the card and ask user for confirmation. Are you sure to do this transaction? But we need a card number. And we provide it to GPT, but it says, okay, I'm sorry, I cannot assist with that. Maybe other large language models will do it out of the box, but here, no. Okay, so we can try to just anonymize the data. Oh, and now it works. It's not. It's from the text above. It's not. It's okay for GPT to extract the card number from it. But for computer, it would be very hard to parse this. We would need. We would have to count the words used, and select the 11th word or something. So we can go a step further and start answering with a JSON formatted document that is, of course, easily parsed by computers. We could also provide answer in a JSON format with something, but this would generate much more prompts. So this by starting answering, we saved a little amount of money. Okay, so hopefully now you believe me that prompt engineering is powerful. So now it's time to know our tools. So to know tools, we need to know what the prompt is built of. Basically, there are 4 basic building blocks. First is the instruction. So a task that we want to solve. In this case, we want to classify into 3 classes. Next, we can provide some context. This is not mandatory, but it can improve performance. So context can be, for example of how to solve these tasks. So the movie was not good, sentiment negative. This shows LLM how to solve such tasks. Then the input data, so basically our question. I think the food was okay, and we want now to obtain the classification. And we can provide also output indicator because not all LLMs will handle it out of the box. GPT probably is powerful enough to just answer sentiment and positive, but not all LLMs can handle it. So it's good to know that by indicating what we expect, we can also improve performance. Right. So knowing it, we move to 3 main use cases for the prompt engineering. So first is solving new tasks without training. So I've shown you these spectacular results from classification. It was solved without the training. So we need to generate a prompt that will solve these novel tasks. Okay, so the most naive approach is a zero shot without any explanation. With this approach, we just said, okay, LLM, generate an IQL query for the following question. We are not providing any details, we're just asking for it. And IQL, by the way, is the database language that LLM can use to query databases. But LLM doesn't know about it. It hasn't seen it yet. But it says, okay, here's your IQL query. But it provides actually the SQL query. So it's told, okay, probably this is a typo. The user meant SQL. I'm providing the SQL query. So instead, we can again do zero shot with explanation this time. So instead of writing, please generate me a IQL query, we explain the concept of the IQL, how the IQL should be generated. So select these filters, you can join them with and, or, and not. Do not give any comments, because as you've seen in the first example, we had some comment that again, we would have to parse in some way. Don't give any comments, just the function calls. Do not include arguments, only the values. And we are almost there, because as you can see, filter by age has greater than sign, and it will not be parsed. The error will be raised. So we need to go a step further and show the third technique, which is called one-shot in this case, but this can be few-shot prompting, when we provide examples of how the task should be solved. So this is this context that I've shown you before. So the explanation is exactly the same, but we say, okay, the example output may look like this. And now the GPT provided a correct answer. So this was the first use case. Next is reasoning and logic. Researchers have proven experimentally that when LLMs, before answering, think about the answer, the correctness is improved. And as you know, we want to maximize the correctness. So the question now is how to make LLM reason in an optimal way. So we start with a task without any reasoning. So this is very well-known puzzle. When I was 9, my sister was 3 times younger than me. Now I'm 50. I needed to make it a little bit harder because the base version is solved by GPT very easily. And GPT answers. And now it is very hard to make GPT answer very directly without thinking. I would need to add answer directly without any thinking, but this is no one prompts this way. I wanted to keep it natural. So LLM does some thinking process, but as you can see, the answer is not correct. So we move to the next technique, which is called chain of thought. And it can be easily implemented by just appending let's think step by step at the very end of the prompt. So now GPT answers, okay, let's break it down. First step, second step. And as you can see, its reasoning trace is much better than it was. But somehow at the very end, it added the number instead of subtracting. So the answer is still incorrect. So we can go a step further and think. LLMs are non-deterministic machines. So here on the image, you see the exactly same prompt and answer as from the previous slide. But I can put exactly the same prompt once more. And now we see the thinking process and the answer is different. But now it's correct. And I can do it again. And now the answer is again correct. So we can say that on average, LLMs are right, And exactly this fact is used in the self-consistency prompting model, which basically works that we prompt LLM few times with chain of thought approach, and then we somehow average the result. In this case, we can just do voting. So 2 votes for 44. So this is the answer. 1 vote for the 56. So 44 is our answer. And people went even further, and the tree of thought was introduced, which basically allows for backtracking and extends, generalize the chain of self-consistency, which is called multiple chain of thought here. And they went even further and proposed graph of thought approach that basically doesn't prohibit to just use the tree. We can use any graph, we can have loops, all nodes can converge to the same result. And they show that performance is improved, but always take into account that these approaches may be generate much more tokens and be much more costly. So again, we want to improve correctness, but also do as short prompts as possible. So I suggest always starting from the simplest techniques, and only if they do not work, go to the more complicated. And the first need is to reduce hallucinations. We know that LLMs hallucinate, and it is a big problem. We want to LLM to give us facts. So yeah, so this is the example from the beginning of the presentation about those 2 directors and incorrect answer. So the answer was hallucinated. So the first approach to solve it is retrieval augmented generation, in which we ask a question and then we provide some context. So here we have details about those directors extracted from Wikipedia. We provide the context, and now the LLM provides correct answer. So we are responsible for providing the context. So we have a question, we compare this question to all the information we have and provide this context. And RAG is very powerful. This is very nice technique. And researchers was thinking what we can do next. And they were inspired by reinforcement learning algorithms, where basically agent reasons in the environment, act in the environment, and then observe some feedback from the environment. And ReACT is exactly implementation of this approach, but in the world of large language models. So LLM at first thinks, okay, and the question is exactly the same as previously compared, are these 2 directors of the same nationality? So first, LLM thinks, okay, I probably need to learn who Scott Derrickson is. And we provide tools to the LLMs that LLM can select to do some actions. And in this case, LLM can do search action, which basically queries a Google search API. So LLM decided, okay, I need to search for Scott Derrickson. So the Google search API is the environment our agent interact with. So we invocate this tool, and the LLM agent observes, okay, Scott Derrickson is this and that. Then LLM thinks, okay, I need to search a dude. Again, it can call the tool, search tool. It observes who is it, and the answer is provided, and the answer is correct. But we can take it even step further. Now, LLM, like we are the final evaluators of the LLM. But if we want to automate it even more, we can have another LLM that does this job for us. So we have a trajectory and some observation by the first LLM, and then the role of the second LLM is to say, okay, is it a fact? Is it hallucination? What could be improved? Why this answer is wrong? And this LLM is called a critique, and feedback of the critique is provided to the LLM, and it can reflect on its behavior and improve upon. Okay, so these are three main approaches to prompt engineering. I hope now you know your tools, but it's not a silver bullet, as I told. So let's move to some problems. So first problem is that we have a lot of LLMs, and they are all different. And unfortunately, most of research done on LLMs is done on the GPT. So we kind of don't know what works best for the plethora of other LLMs available. And they all differ in size. They can use potentially different training strategies and even very different training data. So they will behave in a very different way. So to optimize, we may need completely different prompts. And in case of much smaller large language models, we may need to provide a lot of few short examples so that LLM can understand the task correctly. So be aware of it. And if it doesn't work with smaller LLM, give it a try, maybe try some more prompts or provide it more examples. Next, as these LLMs are non-deterministic, this fact was used in one of the techniques, but in general, it sometimes can be cumbersome. So if you find a perfect prompt and you run it once and you think it's enough, it's not. You should always test your prompts, so generate some validation set, run this validation set through the prompt, calculate the metrics, and if the metric is not high enough, improve your prompts and go back to the step 2. Here you have some tools that you can use for it. And next problem is too long prompts. There was a research called Lost in the Middle, and it find this situation that when we provide document that has the answer in the middle of the context, the accuracy deteriorates substantially. So now it's 55% when the correct document is at 10th position, but when it's on the first position, it's 75%, so it's substantial difference. So it is very important to make sure that the best documents are at the very beginning. You can use re-ranking techniques to make sure about it. And last, don't ask for too many things at once. So here you have example. I asked GPT to provide me a plan, a vacation trip for me. So first, tell me something about destinations, then rank the destinations, get my calendar, look for the best offers online, or book the best offer. And LLM started asking, okay, what about this, what about that, and all these questions. So the token usage was increased because chat history was very big. And when LLM was answering about the best offers online, it has had access to all of the unnecessary information, and we have the lost in the middle problem. So it is not optimal. But to solve this last issue, we have agentic systems that basically divide and conquer. So LLM agent is basically an LLM with additional capabilities of planning, of memory, and having access to some tools. So we've discussed all of this with the prompting techniques. So we can say that, okay, this was actually agents. And all of these things were achieved via prompting. So prompting is very useful if we want to build agentic systems. So basically, the idea is that we have those 5 tasks that are completely separate, and only the consecutive tasks should communicate with one another. So we can create an agent for each task separately. And every agent cares only about its task and provides its answer to the next agent. And this approach is implemented inside the Crew AI framework, which is wrapper of LangChain. And we don't have time to go into details, but basically you define agents in a way I described, then you define a task, and the crew does its job. But it can get very complicated. We can have agent teams, and agent teams can be under supervision of some supervisor. We can have cycles inside. We have ping pong between teams. So it may get very complicated. And for this, you can try Microsoft AutoGen or LangGraph from LangChain. Okay. And with it, let's conclude that prompt engineering is very powerful, and please try it to boost LLM performance. And there are 3 problems that prompting can solve. So new task without training, and we have zero and few shot prompting for it. Reasoning, planning, and logic, and the most popular technique is chain of thought. And for hallucination reduction, we have RAG and React. Next, test your prompts and don't make them too long to encounter lost in the middle problem. And if you are in the situation where many independent tasks need to be done, please use multi-agent systems. Okay, and this is it. Thank you very much.